as I was saying, okay, I said that these equations are important based on what kind of question you are given. So this part here represents the voltage drop across the source inductance. Okay, this guy here represents the voltage drop across the source inductance. 2 over pi. Oh, yes, 2 over pi omega LS blah blah everything like that. This one represents the voltage drop across the source inductance. This one here represents the voltage output without source inductance. So the difference between the voltage output without source inductance and the voltage drop across the inductor is equal to the output voltage. And it makes sense. That's like I said that, okay, due to the presence of inductor, there's going to be some voltage drop across it. Okay, so this is the output voltage. How that's how you can derive it. I think the derivation you can just start from here. You don't have to waste time deriving the current. Since they're just asking for the voltage, you can just start from here to derive it. Okay, that would be enough, I think. Now let us look at the next question. Okay, let me just share the next question. Okay, so we see how we can apply this. Okay, so where is that? Let's see how we can apply this concept here. Oh, and they say also we sketch the circuit. Sorry, I forgot that. So the it also says a sketch. Says what? And sketch the equivalent DC circuit. Okay, so the equivalent DC circuit is this, right? This part here is, remember, it's DC. Okay, output voltage. Okay, so this one will be more like the source, and then the drop is the voltage across the inductor, and then you get the output VO. So these two, they are in series, isn't it? As you can see, they're in series. To get the output, subtract what? The input, DC voltage, minus the drop. So you can actually look at that, isn't it? So I can draw my circuit looking like this. Okay, I can draw my circuit looking at this, plus, minus, this is DC. This is more like the input, right? And then consider the drop across the inductor, right? And then I get the output here. The output is simply the same VO, isn't it? Of course, the current flowing in this direction, right? That current is simply ID, isn't it? So this is this voltage here, what's the name of this voltage? 2 VM, okay? So this voltage here is 2 VM over pi times cosine alpha. This is the voltage that you have here. Minus the drop here. The drop here is simply 2 omega LS ID over what? Pi. And then you get the output voltage. You can actually even apply the KVA or the input, okay? Now the output is simply equal to the input minus the drop, as you can see here. Okay, are we together? So this is a circuit here they are asking us to sketch, the DC circuit. Is that okay? Hello?
Yes, Steve.
Okay, so this is assignment number 3, okay? It's assignment number 3, and also the next question we're supposed to solve in a 2020 paper. 2020 paper, yeah, the one we were looking at last time. Okay, so let's look at the way we can apply this concept. Okay, so let me just bring on question. Okay, let me just bring one question here. And of course, you have to know also how to use if it's a 3-phase. Okay, so sometimes there's 3-phase, the question looks similar. I'm just going to modify it. Okay, so for a 3-phase, so this is a 3-phase problem. The first one we're driving, it was a single phase. Now, how would the two differ if you're using a 3-phase, which if you have source inductance? Let us see how they differ. But I'm not going to do the divisions. I'm just going to point out what is the difference. Okay, let me just point out what the difference is. So let's read the question first. The question says, 3-phase full converter bridge is converted to a 3-phase 400 volt 50 Hz supply having a source impedance of, this should be source inductance, right? Not impedance. They should have read source inductance, okay? Not impedance. Of 5 millihenry. The load current is constant at 20 amps. So you can see that this current here simply, the what? ID, the one which is constant, isn't it? If the load consists of a DC voltage source of 400 volts, okay, so this output voltage, 400 volts, having an internal resistance of 1 ohm. Oh, so we're told that, okay, even there's also some voltage drop across the load, isn't it? Calculate the firing angle alpha and overlap angle mu for this condition. Okay, so let's just list the thing that we're given to us. It's a three-phase, of course. So we have three-phase. Okay, VRMOS, this is supply voltage, right? Okay, so that's the RMS voltage given. This formation is usually it's RMS, steps of RMS. 400 volts. Okay, frequency are given as 50 hertz. Okay, so this information is for AC part. Remember that we are converting this information to DC, isn't it? Okay, and then also given that the source inductance, LS, is 5 millihenry. The load current is constant, so this is the ID, right? Or IO, whichever name we want to use, give it 20 amps. Okay, and then we are given that, oh, in fact, this, the load voltage, this is a DC, it's a DC, right? Okay, the load, if the load consists of a DC voltage, it's equal to 400 volts. So I'm not going to say this is the output voltage. Hold on first, okay? And it has also the internal resistance. So internal, I'm going to denote is IR, R, internal resistance, right? It's 1 ohm. You can give it whatever name you want to use, okay? Calculate the firing angle, so I have to find the firing angle, alpha. And also the overlap angle, mu. Now, it's a three-phase, so we know this is a three-phase. So for three-phase, this is an equation you need to use, okay? So look at this. We are given the source inductance. So we have to use an equation similar to this, right? We are given the source inductance, we are given ID, we are given omega, because if you have no F, we know omega, isn't it? We are given Vm, we have to find the Vo, okay? Vo is given, but it's given indirect to us, okay? So we have to find that Vo first. It's indirectly given to us. So we're looking for alpha, which is the firing angle. So this is the only thing we don't know. So now, since we're doing a three-phase, how is the equation going to be? So to be similar to that, the only thing that we need to consider for three-phase. So for three-phase, this is what it looks. It looks like this. The output voltage, okay, for three-phase, this is the equation you need to use, right? It's simply equal to 3, okay, root 2, okay? So I can, so even I can even say 3 Vm, okay? So I'll come back to root 2 part over pi, okay? And then cosine alpha minus 3 over pi times omega LS times ID. Now, if you look at the, what's the difference here? For three-phase and a single phase, have you seen the single phase? There's 2 here. Okay, for three-phase, there's a 3 here. That's the only difference you need to use. You can see, right? I'm able to tell the difference between the two equations. So this is a three-phase. So for three-phase, I have to put a 3 here. Okay, so these come from also the derivations, just like the one we did above. Okay. Now, remember that Vm is simply equal to what? Root 2 times the given RMS voltage. Okay, so take note of that. So the RMS voltage given to us is simply the 400 volts here, right? Now, we have 2 drops here. We don't only have a voltage drop across the inductor. We also have another drop, which is the internal resistance, right? So that one will count for the total voltage output. So the total voltage output is simply the source voltage, okay, which is a DC. So this one's more like acting like, so can you consider this 400 voltage more like a DC or a battery being charged, that voltage, right? Because this is a load. It's a load. So it's part of the output voltage. And also, you also have to account for the voltage drop across 1 ohm resistor. So the total output voltage will be what? 400 volts plus voltage drop across the resistor is 1 ohm. So how can you calculate the total output voltage? To be 400 volts plus 1 ohm. What is the current through the 1 ohm resistor is what? 20 amps. As you can see, because that's a current that's passing through the output. This is a load here. Okay, you have a resistor there. You have a resistor. So this resistor can be presented by what? Using what? Using a battery, right? Okay, which is 400 volts. And this battery has got some internal resistance of 1 ohm. Okay, so this total here, and then you're connecting to the 3-phase and everything. So this here is actually the total output voltage. Use what? VO. And remember that there's a current flowing through these guys, right? So that current is simply 20 amps, which is ID. So you can calculate that, okay, the output voltage here, VO on its own is simply what? Equal to 400 volts plus the drop across the resistor, 20 times 1 ohm. So the output of DC voltage that has to be supplied, okay, in order to sustain these two, simply what? 420 volts. So this one now we know it, right? We know everything now, isn't it? Okay, even the voltage drop across the inductor. Okay, VLS, I'll call it VLS. Can you calculate what is the voltage drop across the inductor is using this, right? Isn't it? You can just substitute everything in the equation. It's okay. It's 3 over pi omega. Remember that omega is simply 2 pi f, right? Isn't it? And then times LS times ID. You can also first calculate that, isn't it? Okay. So pi and pi cancel out. You're going to have 3 times 2. LS we're given as 5 millihenry. So this 5 times 10 power negative 3. Oh, we also have frequency 50 hertz. Okay. ID is given as 20. So how much is it? The voltage drop across the inductor, VLS. Okay. How much is that? So let's calculate together. So 3 by 6, or 3 by 2 is 6. Okay. Times, okay, 5 millihenry, which is 5 exponent negative 3, times 50 times 20. So I'm getting about 30, right? That's 30 volts. So that's the voltage drop that is across the inductor. Okay. Now having everything here, you can go ahead and find the alpha, because that's the only variable missing, isn't it? So VO is 420. Okay. This is equal to 3. What is VM? Remember that VM is simply square root of 2 times RMS voltage given to us, which is 400 volts, right? Over pi times cosine alpha minus this part, you've already calculated it, which is 30 volts, right? Okay, so let us move this 30 to the other side of the equation. Obviously, we're going to have 450 here. This is equal to 3 times root 2 times 400 divided by pi. Cosine alpha. Okay, so let us solve for alpha. So cosine alpha will be equal to 400 times pi, or 450 times pi, divided by these guys, right? If you do the cross multiplication there, 3 times root 2 times 400. So let's see. So 450 pi over 3 times root 2 times what? 400. So I'm getting 0.833. Okay, 0.4. So to find alpha, I can just take cosine inverse of that. Alpha is equal to cosine inverse of that. So how much is that? So I'm getting 3.59. 59 degrees. So this is a firing angle that you need to apply in order to achieve the output voltage of what? 450 volts as a DC voltage. Okay. Are we together? Now from this information, we can now go ahead and find what? The overlap angle. Remember that there are two equations. These two equations are very, very useful. Okay, these equations that I marked. this one here and this one here. So this one, we found alpha. Since now we found alpha using this equation, you can use this other equation and find what? Overlap angle, which is mu. Okay? Take note of that. So for us to find the overlap angle now, we're going to use this equation. So VO is equal to, okay, where is that? Okay, this is
So
V.
still, since this is 3-phase, it's going to be 3 VM.
Sorry?
I'm saying since this is 3-phase, like this question is a 3-phase question. So it's going to be 3 VM over pi.
Yeah, since it's 3-phase, this is an equation you need to use, right? Okay, let's. So it's going to be 3 VM over, not pi, it's actually over 2 pi for 3-phase.
Come again?
Okay, it's over 2 pi, not only pi, it's over 2 pi.
Over 2 pi.
Yes.
Okay.
So for 3-phase, so take note of that. Let me just write it here. For 3-phase, this is an equation you have to apply, 3 VM over 2 pi. And then everything is at the same, okay? Which is cosine alpha plus. So when you're done with this, so please get assignment number 3 and go through it on your own and understand it better, okay? Mu times that. Okay, so this is it for the 3-phase. And then for single phase, remember that for single phase it was what?
So Steve, why 2 pi down
It
there?
actually comes from derivations, so I can't start doing all those derivations, please, time.
Oh, okay. No, I just asked.
Yes, that's the derivation. Okay. All right. For single phase, the one that we looked at on top there. Okay. All right. So now let us proceed. Okay. Of course, the over 2 pi is because of the difference in periods, right? The period is actually different when you consider the 3-phase. The 3-phase has got 6 pulses, so the period is be different as compared to this one where the period was pi. So that's the reason. If you want plate and all those derivations, you achieve that. Okay. So now let us look at it. Everything given to us now. VO, is 450. Sorry, VO is 420. Okay, we found VO, which is 420, right? Was it 420, right? Yeah, 420. From the previous problem, isn't it? From the first part.
Yes.
So 420 is equal to 3 times VM is simple root 2 times 400 divided by 2 pi cosine alpha. We found alpha to be 3.59 plus cosine, and then 3.59 plus mu. Okay. All right, so now let us try to solve this. So I'll send 2 pi to the other side of the equation. So we have 400 or 450. So I'll first write this side of the equation, which is cos 33.59 plus cos 33.59 plus mu. This is equal to 420 by 2 pi divided by 3 root 2 times 400. Okay. Now I'm going to send this guy cos the 3.59 to the other side of the equation so that I just remain with what? Cosine the 3.59 plus mu. This is equal to, so let me just simplify this, okay? So 420 times 2 pi, 420 times 2 pi. Hey, what's up? 420 times 2 pi over Yeah, what's wrong with this one? Trying to use calculator. Of course, I know these people don't even come up with the calculator. Don't even know who will be punching. 400. So I have 1.55. 009, okay, and then minus cos 3.59. Okay, so now the next thing that I can do is just taking the cos and inverse of this both sides. So let me first subtract these two. So I'm going to subtract this guy here, right? Minus cos 3.59. So this side I'm getting 0.721991. Okay, something like that. So that this side I'm still having cos 3.59 plus mu. Okay, so at this point, I'm going to take cosine inverse of both sides, right? So I'm going to take cosine inverse of that side. So cosine inverse of this guy. Even here, I'm going to take cosine inverse of this guy, right? So if you do that, cosine inverse times cos, these guys cancel out. Cosine inverse and this cosine, they'll cancel out. So that just means with what? 3.59 plus mu equal to cosine inverse of that. So you just have to take cosine inverse of that guy. So cosine inverse of this is simply what? 43.780875, right? Something like that. And then you have solving for mu. So taking the 3.59 the other side of the equation. So 43.78, whatever minus it, 3.59. So from this, you're able to get what? The overlap angle equal to 10.19 degrees. Any question?
No.
Others? Others, they don't talk. Okay. How many minutes am I remaining with? Let's see. This Zoom is a free one, so obviously anytime it's going to be given a warning. Okay. Okay, so let's look at another question again on the same from assignment as well. Okay, so this is the next problem. So if you notice here, we're given almost all the information that we need. So we have to make choice of the question you need to use. So here is the question. It says the 3-phase 6 pulse. Okay, so this 6 pulse part is unnecessary because we know that 6 pulse, of course, it means it's a fully controlled, isn't it? I mean, yeah, it's a full controlled, right? Full wave, fully controlled. Converter is connected to a 3-phase AC supply, 400 volts, 50 hertz, and operating with a firing angle of alpha equal to pi/4. The load current is maintained constant at 10 amps, and the load voltage is 360 volts. Calculate the load resistance, source inductance, and overlap angle. Okay, so you see that here now we are given firing angle, and we need to find what? The source inductance. So you know which equation you need to use. Okay. All right. So it doesn't matter which one you start with. In this case, I think you can start with either finding the firing angle or finding the overlap angle, or first finding what? Either of the two, those two work. I think in this case, let's see the data that is given to us. So what we are given here is on the AC part. On the AC part, what we are given? On the AC, we are given the 400 volts, and you know this is always RMS voltage, okay? This is RMS. We're also given the frequency 50 hertz, okay? And you know this is a three-phase, okay? And then we're also given alpha equal to pi over 4, which is 45 degrees, okay, or 45 degrees. What else are we given? We're also given the load current, okay, which is I name it ID or IO, which is 10 amps. The load voltage, the voltage output is a load voltage because this is a load we are supplying. We are converting this 400 volts to some DC, and that DC is simply what? 360 volts in this case we are given. Okay, now we have to find what? Okay, what is missing? What are the missing variables here? So the missing variables are what?
LS.
Okay, so calculate the load resistance. So R, L, LS, and mu. So we have to find these guys, right? These are the values you need to find. Okay. Okay, so since that is what we are given, you can find what? The first question, the first part of the question, in name it A, you can find the load resistance. Okay, this is very straightforward, right? So load resistance is what? The load voltage, the output voltage, right? Because you have connected the load, right? So consider this the load, right? From here there's some conversion happening, three-phase, but this is a load. And on the load, you have the output voltage, right? The load voltage is what? 360 volts. So this is the output voltage, 360 volts. And okay, this is a load. You also have the current flowing through that load. You are given that's the constant current 10 amps. So you know the current, you know the voltage, you can find what? The resistance. So it will be V over ID. Okay, VO over ID or VO over IO, whichever. So VO is simply 360 volts. And then you have that gap is 10, right? So the load voltage is, the load resistance is what? 36 ohms, okay? You have 36 ohms there. That's the end of the first part of the question. So I found this guy. Now let's find LS. So part B, remember the equation that we need to use for three-phase, right? Okay. So for three-phase, remember that the VD or the V out is simply equal to 3Vm over pi. Okay, so the two equations, but since we need to find the LS, we have to use this one, isn't it? The first one, right? And then cosine alpha minus 3 over pi omega LS times ID. Okay. So this is a variable that we're looking for. We need to find LS. We have this ID, we have everything as you can see here, isn't it? Right? So let us find the LS. 10 minutes remaining have been on. Let's hurry up. Okay, so now from this, let's substitute everything. VD is given to us at 360 volts, right? 3Vm will simply root 2 times 400 divided by pi. Cosine alpha is given to us as 45 degrees. Okay, I'm going to use degrees instead of radians, but it's whichever if you want to use radians. Just make sure you get a radian mode. Okay, 3 over pi. Omega is 2 pi times frequency is 50 hertz. Okay, so we're trying to look for what? This guy LS. Okay, that's the missing variable, right? And then times 10 amps. Okay. Let us quickly find that. Okay, let us quickly find that. So 3 times 40, 2 times 400 times cosine 45. Okay. So Here I have 360 equal to, this is 1,200 over pi minus, okay, so here what do we have? We're going to have 3 pi and pi cancel out, of course, this pi and this pi cancel out, so this will be 3 times 2 times 50 times 10, right? So this is 3,000 LS. Okay. Now I'm going to move 3,000 LS to the left hand side, and then I'll move 360 to the right hand side, right? Okay, something like that. So let's see. So 1,200 over pi minus 360. So I have 3,000 LS. This is equal to 21.97186. Okay, so you divide by 3,000. So LS is equal to, so that divided by 3,000. I'm getting about 0.0073, about 24 henries, which this can be written as what? 7.324 millihenries. So that's a source inductance, okay? And then lastly, we have to find the what? The overlap angle. Of course, you know which equation to use this time around. So VO is simply equal to 3 Vm over 2 pi. Okay, and then bracket cosine alpha plus cosine alpha plus mu. So 3VO, we know 360 already. So even this one you could have used without even finding LS, okay? Because everything is there, isn't it? Okay, root 2 times 400 divided by 2 pi. And then cosine 45 plus cosine 45 plus mu, right? Okay. So let us quickly solve for this. So this will be cosine. How many minutes am I remaining with? 6 minutes. Let me hurry up. So cosine, I'm just trying to do the cross multiplication here. Cosine 45 plus cosine 45 plus mu. And then this will be 360 times 2 pi divided by 3 times root 2 times 400. Okay, so let us see that. So 360 by 2 pi. What's happening? 360 times 2 pi. Okay, 3 times root 2 times 400. Okay, so from this you are getting a 1.332. Okay, 864, something like that, or 65. Okay, and then you can subtract cosine 45. So cosine of 45 plus mu equal to, so what is it? That answer minus cosine 45. So this is 0.625. 758 1, right? So if you take cosine inverse of both sides, that's like before. So this side is going to be with 45 plus mu. What is the cosine inverse of this? Okay, so cosine inverse of the answer. This is 51, right? 51.262, right? And then if you subtract 45, you get mu equal to 6 point something, right? 6.26 degrees. Okay, so that is our overlap angle. Any question, please? Any
Yeah,
question?
Masha.
Okay, so let us come back. We look at the other questions as well. Okay. I'm ending the meeting now. Wait before you join. Wait for about 10 minutes before you join. Okay.
Okay.
Yeah.